All right, so Chapter 6, Section 1A is going to introduce the next major topic in this course, which is trigonometry. Now, you guys have done trigonometry before, right, in geometry. Now, you guys, if you remember sine, cosine, tangent, right, all that stuff that you did with right triangles was a little branch of trigonometry. We're going to start this topic using degrees because that's what you all are most familiar with. We're going to start with a discussion of angles, specifically angles in a coordinate plane. So trigonometry is just a branch of math that's focuses on the relationships between the sides and the angles of a triangle, right? Hence that part of the word trig, right? Tri. So that's what you can expect in the remainder of this chapter, right? As you can expect to see some triangles down the line. I'm not really going to use them yet, right? We're really just basic discussion on angles. But you'll see the triangles come into play and how this is relevant in the next section. All right, so we're going to start with degrees on a coordinate plane. Now, degrees is just a way that we measure an angle, right? And if you guys remember from geometry, an angle in its most basic form is just the measurement of the space between two rays, right? If you guys remember, a ray has an endpoint, right? But it doesn't have an end, right? It just keeps going forever in one direction, right? So if I have two rays right here, right, this angle this measurement that's formed between these two rays is what we call an angle, all right? And now we take this concept right here and we put it right on a coordinate plane, right? So this coordinate plane, I can call this the x-axis and I can call this the y-axis, right? So now getting into the anatomy of an angle in a coordinate plane, you have an initial side. Right, so the initial side is always going to be where you start, right? So what does initial mean? Initial is always the starting, the beginning, right? So this right here is always going to be your initial side. And then as you can see, it's always going to be on the positive side of the x-axis, right? And so where does an angle end, right? Terminal, right? If you guys know terminal, means the end, right? The finish of something. So this ray right here is going to be your terminal side. And then this measurement between the two, this is going to be your angle, right? So this symbol right here, we call this theta. All right, so maybe you've seen it before, maybe you haven't. It is a Greek letter that is denoted with this, it looks like a 0 with a slash through it, right? So this is theta, and we use this to denote an unknown angle, right? If you remember in geometry, you typically just solved for x and y, and like sometimes x and y would be an angle measurement. But here we already have an x and a y, right? Here x and y actually mean something because we're now applying angles on a coordinate plane. So we have another variable, right? We call it theta, and that's typically what you'll see is going to denote an angle. All right, now on this side, now you can see we have another one over here, right? But on this part of our, on this slide, this represents an angle with a positive angle of rotation. Now what that means is you're rotating counterclockwise, right? So positive in this case is going to mean counterclockwise. All right, so you can see this specific angle that's shown here. I don't know what measurement that is. I'm going to say that this is about, I don't know, 45 degrees. All right, it looks about in the middle, right? So I'm going to say 45 degrees. I don't really know how much. But if you keep rotating, right? So if I keep going in the counterclockwise direction, right? So I go a little bit more. And if you reach this part of the y-axis, right, so the positive part of the y-axis, right, what angle do you think that is? Right, it looks like, if we remember, this is going to form a right angle, right? And a right angle is 90 degrees, right? So this is a 90-degree angle, and we're always going to start at 0, right? So let's say we have an angle whose two rays are right on top of each other, right? That's going to be a 0-degree rotation, right? You're not rotating at all. You're always starting at 0 degrees. All right, now if you keep going a little bit further, right? So from this 90 to this part of the x-axis, you see that we now have in total from this part of our initial side, right? So if you remember, the initial side is always going to be the positive part of the x-axis. Going all the way around to the other side, this is going to get us 180 degrees. All right, and it looks like we can keep going even more, right? The other side of the y-axis this is where our new terminal side is. We can say that this is 270, right? It's another 90 degrees, right? I have a right angle. All right, and then if you keep going all the way around, we have another right angle, right? And you can see that if you go all the way around, the shape that I kind of just drew is a circle. All right, now a circle, the total angle measurement of the circle is 360 degrees, right? Now keep that in mind, right? Because notice that a full rotation starting from our initial side all the way back to our initial side is 360 degrees, meaning that if you do a full circle rotation, then you end up in the exact same spot. So let's say I had an angle right here. All right, I'm going to say that this is about 120 degrees. Right, because again, remember, our initial side is always where we're going to start, and then it looks like I'm about right there at 120 degrees. How do I know it's about 120 degrees? Because you can tell that it's a little bit bigger than 90, right? But it doesn't go past 180. Right, that's where our 100-degree or 120-degree angle is, right? And then notice that you can kind of characterize all of your angles in this manner, right? So if we remember, the coordinate plane can be divided into quadrants, right? So I have my first quadrant here, my second quadrant here, my third quadrant here, and my fourth quadrant right here, right? This should be very familiar. Notice that each quadrant has a designated angle interval, right? In our first quadrant, we have 0 degrees to 90 degrees, right? Going up to that first, this first little section going up to the y-axis got us 90 degrees. And if you kept going from 90 degrees to 180 degrees, gives us our second quadrant, right? All of our angle measurements between 90 and 180 are in the second quadrant. And you can do the same thing with the rest of them, right? So between 180 degrees and 270 degrees, we have all these possible angle measurements that are in the third quadrant. And then same thing with the fourth quadrant, right? The fourth quadrant contains all of the angles between 270 and 360 degrees. All right, so lots of important things to keep in mind. Everything that we just said about these angles of rotation can be done exactly the same way, just in the other direction. Right, now these are what we call angles with a negative angle of rotation. Again, we have the exact same initial side. Everything is exactly the same. Right, so this is our initial side, and our terminal side is going to be where it ends, right? But notice that now you're going in the opposite direction. Right, so a negative angle of rotation is going to be clockwise. But again, you still have the same idea, right? We're always going to start at 0 degrees. And then now, since we're going backwards, I'm going to call that negative 90 degrees. All right, and because I'm going backwards again, I'm going to call it negative 180 degrees. Go backwards again, I have a negative 270 degrees, and then go backwards again, you end up in the same spot. Negative 360 degrees. All right, so same thing that we just did, just again in the other direction. That's the only thing that changes, right? So for example, if I pick the exact same angle that I used in the other one, right, that I said that this was about 120 degrees, right? So approximately 120 degrees in the positive direction. Now we can go in the negative direction and say, okay, it's a little bit bigger than 180. So I'm going to say that this is about negative I don't know, 240. I'm just gonna guess. And that gets us pretty much in the exact same spot, right? So that's just another way that you can write angles, right? This time you can do it in the negative direction. All right, now lots of talk. I know I was talking for kind of a long time, but it helps if you really understand this first little talk of angles before moving on to any other section. All right, we're now going to talk about coterminal angles. All right, we know what a terminal side is, right? A terminal side is just where it ends, right? And then this prefix co just means to share. All right, so if you can piece together each part of this word, right, you can probably guess that coterminal angles are angles that share the same terminal side, right? So a coterminal angle has the same initial and terminal side, but more or less rotations around the circle, right? So if I'm just going to draw a quick sketch of what this means. If we draw, let's say, I'm going to say, right, we always say that our initial side is on this side of the x-axis, right? So I'm going to say that's my initial side, and then my terminal side I'm going to say is, I'll do the same thing that was in the previous slide, right? Something like that. And then this is our angle right here, right? Theta. All right. Now, I'm representing this angle with just this little arrow, right? This little arrow right here. But what if I went all the way around, right? What if I went around a full circle and then still ended up at the same spot, right? You do end up at the same spot, right? But notice that now I looped around one full circle before ending up at this same spot, right? So same thing is you can go kind of in the negative direction, right? So let's say I'm gonna have the same initial side, and I'll even do the same terminal side, right? So I'm gonna have a terminal side right here, and then again, right, this is our original angle, theta. Now what if I went in the negative direction? So I'm gonna go backwards from where we started, right? I'm gonna go backwards, and then you end up here at the same spot. All right, now I can go back again, right? If I go back a full circle and then back again, right, I see a whole bunch of spirals right here. I just keep looping and looping around. But with circles, right, you're allowed to do that, right? You're allowed to go around a full circle and still end up at the same spot. All right, that's why, like, in colloquial language, right, if somebody's talking and they're like going in circles, right, they're really not going anywhere, right? They're kind of just saying the same thing over and over again, right? I know I kind of do that a lot in class, right? But that's kind of the idea here, right? If you're going in circles, right, you're going to end up at the same spot. Now to find a coterminal angle, you're going to add or subtract 360 degrees. In our directions, sometimes I will specify if you need positive or negative coterminal angles. This last bullet seems pretty self-explanatory, right? If I'm asking you for a positive coterminal angle, you should give me a positive one, and if I'm asking you for a negative one, you should give me a negative. All right, so here we want to find two coterminal angles, one negative and one positive. So let's look at number one. All right, so I have 908 degrees. That is a really big angle, right? Now, with any coterminal angle, you could add or subtract. So I could do plus 360 degrees, right? And then you get, I think, what does this get you? 1268, right? But that gets you a really big number, right? So I don't really want to use that as an answer, even though it does work, right? So this is a coterminal angle, right? I don't really want to use this as an answer, though, because we also want to find a negative one. So I can also subtract 360, right? So subtract a full circle, and you should still get a coterminal angle, right? So this should get you 548 degrees, and then that works, right? That's another coterminal angle. So this is a coterminal. This is also a coterminal, right? But again, the objective is I want one positive and one negative, right? So to find a negative, I'm just going to keep going backwards, right? So I'm going to subtract 360 again, right? And if I subtract 360 again, you get 188, right? That also works, right? That's another coterminal angle. But again, I want a negative one. So I'm going to go backwards again, right? Minus 360, right? And this should get you negative 172. And now we finally have a negative coterminal angle, right? So any of these work, right? So this negative 172 for sure works, and then you can pick any other one as your positive one. We have 3 positive ones. All right, but that's essentially the idea of how you find a coterminal angle. It should be pretty easy. This next one should also be pretty easy. I'm actually going to draw this one, right? So first I'm going to find the angles, right? So it's already a negative. I have a negative 75, right? To find a positive coterminal angle, right, I can add 360 degrees, right? And that should get you 285, right? So 285 degrees, right? That works. And then I can also subtract, right? So I can take away 360, right? Go backwards a full circle. And this is going to get us negative 435. All right, and that's our negative coterminal angle. Now, I told you I would draw this one just to kind of get the idea more clearly across, right? So I'm just going to show you guys. Negative 75 degrees. Well, I know that that's between 0 and negative 90, and it's negative, so I'm going backwards, right? So I'm going to expect it to be right here, right, in the 4th quadrant, right? So this is going to be negative 75 degrees. All right, so because again, right, 0 degrees, right, negative 90 degrees. That was in the previous slide. Now I can go from this side right here, I can go backwards a full circle, right? And that gets us that negative 435. All right. And then from this terminal side again, I can go now forward, right? So I can go in the positive direction. All right. And that gets us, even though we went forwards 360 degrees, right? But this was our initial side, right? This is always going to be our initial side. So starting from here, going all the way around, right, you still end up at the same spot, and that's going to get you that 285, right? And 285, it does check out, right? Because I know that in the positive direction, right, I had a 270 right here and a 360 right here, right? And 285 is between 270 and 360, and it does end up in the exact same spot as we expected it to, right? So that's what it looks like visually, right? You're just going forwards or backwards however many circles. All right. Now this third one, again, same exact idea, right? It's already negative, so I'm going to go ahead and add 360 to get a positive answer. All right, now if you add 360, you get 157 degrees. All right, there's our positive coterminal angle. Now to find a negative coterminal angle, I'm going to subtract 360 degrees. All right, and that's going to get us negative 563 degrees. All right, and now this last one, 699, again, it's already positive, so you could add if you wanted to. I want to go backwards because I also want to find a negative one. So I'm going to subtract 360 degrees. All right, and that's going to get us 339. Right, that's a positive coterminal, and then I want a negative, so I'm going to go backwards again, right? So I'm going to minus 360 from here, and then you should end up with negative 21 degrees. All right, and there's our negative coterminal angle. All right, those are the only kinds of problems that we're going to really cover in this particular lesson. It probably seems not very useful right now, but down the line you're going to see that finding coterminal angles are actually going to be very useful. But for now, it's just an easy skill that you guys should hopefully be getting comfortable with.